and you're searching for a program called Interactive Physics 2000. Okay, so just type in INT, it should pop up. You guys don't have that in the program. Now, here's where this gets a little bit weird. You're going to have to open a file called Lunar Modification for Burkamp. But the files are located on these thumb drives. Okay? So when you get logged in, come up, grab one of these. This is what the program is loaded on. You don't have to keep this in while you're running the program, because this is just like a shell of a program. So once you get the program up and running and you open up this file, take it out, put it back up here so that the next person can come and grab that thumb drive. Okay? So come up, get logged in, boom, here you go. So you can open up this program, and it'll be the only one that says anything close to lunar on the disk. So this is going to open up, and to clear out that velocity time graph, just click in that gray area, and it goes away. Now, sometimes the program might ask you for the last word on the last page or on a particular page in the operator's manual. The manuals are up here. They do that as like a safety feature to make sure that you don't have a bootleg copy of the program without the manuals that go with it. So it might say, like, what's the last word on page 4-3? So you're going to come up here, get this book, find 4-3, and you would say, type in the word menu. Okay? So, or whatever that is on that particular page. It won't do it all the time, but if it does, here are the books that you need to come up and access. So, once you get logged in, and if you look at the parameters, and we'll just go through this, you're just going to hit run, and I want like a couple of direction changes. Okay, it doesn't have to be anything dramatic. And there's one, there's two. Oh, come back down here. Oh, there's a little boy. And there we go. Okay. Thank you very much. Years of practice. Like, what are you working on? Lesson plan. Okay. Just a second. Or flying the helicopter. Okay. So, when you get it done, okay, and again, I want like at least 2 direction changes. So basically, this actually has 1, 2, 3. Okay, if you really want to get picky, but a minimum of 2. You're going to land it here. Now, on page, let me see that. Over here on page 3, there's some data that you have to get from the program. So once you've successfully landed it, here's what you're going to do. You're going to go here and you're going to record data from the program, okay, at a particular point in time. I don't care which point you pick. So if I were Bree, I'd come in here and say, okay, at this point, my acceleration in the y is 0.01 meters per second squared. So where it says, over here on page 3, where it says AY, boom, 0.01. Then it's got velocity in the y, negative 0.59. And then I've got the value of the main thruster, 8,400. This 8,400 newtons is your applied force. Okay, it isn't your net force, it isn't your opposing force. And yes, we're still using the same parameters here that we used on page 1 and 2. Of course, Bloch struggled with that concept. It's still the same thing. Gravity, acceleration due to gravity is still negative 1.67. The mass of the ship is still 5,000 kilograms. If it was anything different, I would have to tell you. And since I don't tell you that it's anything different, you go, oh, wow, those are the same values. So, these are the 3 numbers that you're going to write down. So then, what you're going to do is you are going to calculate the net force, okay? And what you're going to do is you're going to show me, preferably like the chart, and you go, oh, here's my applied force of 8,400 newtons. You're going to have that number. You're going to have that applied force. Then you're going to have the same opposing force of 8,350 that you did before. And then you're going to calculate the net force, and you're going to divide that net force by the mass to get the acceleration. Because here's the golden rule, especially with computer programs. You never trust the computer program. you always go through and do your own calculations to make sure that the computer program is matching up with what should happen. So what you're going to do is you're going to show me how you independently verified the acceleration. So you're going to calculate the net force by adding the forces together. You're going to take that force and divide it by the mass to get the acceleration. Hopefully the two accelerations are the same. Okay? Hopefully the computer program's working like it should. Then you're going to look at your data and you're going to tell me if it's speeding up or slowing down based upon the acceleration and the velocity. So then, that's going to be one point. So if you come down here in the bottom left, there's a little scroll bar, and you can replicate. So then you're going to come in here and go, okay, so this would be my other data point. I got a value of 6,600. I got an acceleration of negative 0.35, velocity of 0.15. Again, you're going to go through, use this as your applied force, calculate the net force, see if it's the same. Now, on this acceleration of the main value of the main thruster, on your two different data points, I want these to be vastly different in terms of the value of the main thruster. So in other words, don't have 6,600 on both values, okay? I want two completely different values of the main thruster, okay? Vastly different, like far apart. So then you got those calculations to do. Then you got a series of questions to answer here. And then over here on the back side on page 4, I've given you like a typical velocity time graph. So what you want to do on this velocity time graph, up here I'll tell you, you want to label every section of the graph where the limb is speeding up or slowing down. I'd recommend that you use up arrows and down arrows. Okay? And again, the up arrow doesn't mean that it's going up, it just means that you're speeding up. And the down arrow would just mean that it's slowing down. If you want to write SU, like speeding up, and SD, slowing down, cool, or you can just use arrows, whatever works for you. Then, you're going to label every section of that graph where the net force is positive and where the net force is negative. Okay, so those are going to be the two things. So I should clearly, and I mean clearly see, and make sure that I see what you have as like a key. What does up mean? How are you designated up? How are you moving down? That type of thing. So don't make me kind of sort through and guess what you've done on that part of it. Now, to add to the challenge, okay? So once you get successfully landed, if you want, there's an opportunity to get 5 extra credit points. Extra credit points are rare in this class. So here's how you're going to get the extra credit. So you're going to go through and you're going to successfully land the ship, meaning that you have 2 vertical direction changes. And what I'm going to do is I'm going to add together your velocity and your acceleration. So whoever has the largest negative sum of velocity and acceleration gets the 5 extra credit points. Then you can work together as a group. If you want, you can like no more than like 2 people. So like if you look, that was like the data from first block. So basically what you want to do is land with the biggest possible negative velocity and the biggest possible negative acceleration. Now, keep in mind, if that velocity is bigger than -1, it crashes and burns. So your velocity has to be less than -1. So if you do the math, you want the biggest possible negative velocity. Well, your velocity has to be negative to land anyway, otherwise you're going up and you're not going to land. So your velocity by default has to be a negative number. The wild card is what you do with your acceleration to get that to land. Okay? Any questions? So, after I sign off, and I'm just going to sit up here at the corner. So after I sign off on it, and if I send you back, don't take it personally. Okay? Don't take it personally. I'm going to say, hey, this is wrong, and this has to be corrected before I turn you loose. So then you can grab the laptop, fire that puppy up, and you're off to the races. Okay? We're good. This is due tomorrow, even if you get done today, which is unlikely, but if you do get done today, just hold on to it and I'll get it tomorrow. Any questions? Okay, all right, so